Welcome to the Nature Series. On tonight's episode, we are going on a wild adventure, deep into the heart of the American Southwest. This region, known as Bryce Canyon, has a brilliant history, millions of years of geologic and weathering processes. What makes this area famous is its hoodoos, which are grand limestone columns that are over 100 feet tall. So join us as we explore how these features originated and why they are unique to this region.
Imagine back 60 million years ago to a time before this canyon existed. At this time, the entirety of southern Utah was covered in lakes. As small organisms died, they settled at the bottom of the lake along with sediments that ran into the lakes from surrounding watershed. Over time, these sediments built up in thick layers. As more and more sedimentary layers form, increasing pressure is exerted on deeper layers, lithifying the sediments into things such as limestone, siltstone, sandstone, and shale.
13 million years ago, uplifting of the Colorado Plateau put the area under a lot of stress, causing the plateau to break into many smaller pieces. The uplift of this region increased the grade of the small plateau that is to become Bryce Canyon, causing the gentle braided stream that once existed there to move with more energy, allowing the water to cut through the soft rock layers. This stream is now known as the Paria River and is responsible for carving out the canyon. Due to pressure buildup in the rock, deep cracks and joints were created. These joints then have the potential to fill with water, which then freezes at night during the winter, forcing the rock apart through a process called frost wedging. The loosened rocks then are forced down into the canyon by water, leaving behind vertical columns called hoodoos. Monsoon-type rainstorms pass through this area during the summer, washing away the debris and aiding in physical erosion processes. This clears out the buildup of loose sandstone and eroded sediments. The rain in this area is slightly acidic and can slowly dissolve limestone, leaving behind the more durable mudstone and siltstone layers. This creates the smooth and bulged shape of the hoodoos. Many of the more durable hoodoos have dolomite caps on them. Dolomite dissolves at a much slower rate due to its high magnesium content, protecting the weaker underlying limestone from chemical erosion. This leaves us with the hoodoo shape that we see now, smoothed, rounded hoodoos with caps that are durable and resist further erosion.
The hoodoos in Bryce Canyon and their complex erosional patterns are truly spectacular. But, as all good things come to a close, soon will they. At their current erosion rate, the hoodoos will be completely eroded away in less than 3 million years, leaving behind a steeply walled canyon with a large river running through it. While this is a sad fact to realize, one can relish in the fact that just as Mother Nature takes away her works of art, she creates new ones in their place. Only time will tell the next installment in her portfolio.
Thank you for joining us this evening on the Nature Series. Tune in next week when we interview top geologists to find out what their favorite geology jokes are. Have a nice day!